What if this was what independence looks like? If you recall, I told you 6 months ago about China's tightening grip on lithium technology. By then, it was a story in development with early signs of its materializing, but it became much more tangible this July as China actively enforced its lithium technology export ban. But you know what? I may be standing inside Britain's answer. 7.2 cubic meters per hour, 96.5% lithium purity, zero Chinese technology, or at least non-ISO, and honestly, it's beautiful to watch. While I was touring Northern Lithium's site in County Durham, riding a bus around the catchment area, watching engineers pull lithium from Yorkshire water like it's the most natural thing in the world, China was actively enforcing its lithium technology export restrictions. In retrospect, the timing couldn't have been more perfect. Here I was, seeing a completely independent solution working in real time, just as the industry's biggest suppliers slammed the door shut. But you might be wondering, what takes me to beautiful Newcastle? I bumped into Andrew Walker from Evolve in Amsterdam, and being a kind British, he invited me to see their pilot plant with Northern Lithium and RSC Engineering firsthand. Needless to say, I was genuinely excited. As you may recall from my own Lecker Lithium experiments, I've been looking into Evolve's tech for years now, watching them develop something that actually made sense from a water treatment perspective. But there's still a difference between understanding the theory and watching it in action in a muddy field in County Durham, where they co-developed something entirely new with Northern Lithium. What I witnessed on that sunny day along investors, potential customers, some press, and quite a bunch of farm animals was pure validation. I may have been the first to raise questions about membrane selectivity and divalent ion removal, but here it was, processing real brine and hitting real numbers. And beyond those numbers, there was that subjective feeling in the air. Everybody looked genuinely happy. Not that forced, everything's fine smile. Really, these people were proud of what they'd built. And they had every right to be. I quickly touched on the results in my intro. 92% end-to-end lithium recovery, 96.5% purity, with calcium and magnesium so low they couldn't even detect them. Zero water footprints because they recycle everything. Zero chemical footprints because they regenerate their own acids and bases. But maybe even more meaningful if we zoom out, the setup of that project was also an opportunity for Evolve to validate its predictive models, potentially accelerating deployment for future projects thanks to an even greater understanding of the intricate mechanism at play in brine mining. In the lush Newcastle hinterland, they collected 78 million data points that match and solidify those said models. They stress-tested everything to push technologies beyond normal operating limits, broke stuff on purpose just to see what would happen, then fixed it and documented exactly why it failed. And that lab is not closing anytime soon. It will be a playground for the next iterations of Evolve's technology, as I'll discuss with Andrew in a minute when we talk Separonics' 99.1% selectivity while maintaining superior flux rates. If you know, you know. We'll also discuss why approaching lithium extraction from a water treatment mindset rather than mining perspective enables modular, scalable, and familiar solutions, also addressing zero water and zero chemical footprint perspectives for DLE thanks to that twist. Maybe even more important, we'll talk opening the black box, bringing transparency to DLE flow sheets, and enabling a better Lego brick type of collaboration that might be the future of that fascinating field. 3 years from now, when Northern Lithium's commercial production hopefully starts, this won't look like a traditional mining project. It will look like what it is, a water treatment facility that happens to produce one of the world's most valuable materials. So enough vlogging, let's get to talking this out with Andrew. Right after I remind you that if you like what you hear, please take this episode and share it with a friend, a colleague, your boss, or your team, and I'll meet you on the other side. Hi, Andrew. Welcome to the show.
Antoine, thank you very much for having me. Really appreciate the opportunity.
Well, actually, I am in need of that opportunity today because you were kind enough to invite me to your site visits in northern UK, northern England, south of Scotland. How do you call Newcastle?
It depends if you're Scottish, if you're English, you're Welsh, or if you're from the UK. But if you're from France, I guess you'd just say something like northeast of England. How's that?
Sounds good. Well, actually, I had the pleasure to see your lithium demonstrator you're doing with Northern Lithium. It seemed to be like very efficient, very well done, beautiful scenery, lots of happy people, lots of smiling faces. But if you have really to catch people with just one single reason why that one stands out, what would it be?
I think the client is very brave and entrepreneurial. And the reason that I say that is that they went from fairly early stage processing of their brines in our facilities to already a pretty large scale demonstration plant processing 7.2 cubic meters an hour. That's a pretty big plant.
So tell us about the project. What are they exactly doing at that stage? So what are you actually exactly doing at that stage?
Well, I think it's a combination of proving the asset itself, which is obviously our customer's main business, not our business, but how does the well perform also over time? And there's a theory here that the well has, I wouldn't say infinite reserves of brine, but that theory seems to have been validated with long-term pump testing at a certain quantity as well. So that's the one objective. What can we get out the well? And the second one, from a DLE perspective, which is where we come in, is does the technology work as we've already done it on a stale brine with a live brine? And can we gather enough data from that trial in order to validate our models, digital twins, to draw conclusions not only for this scale of plant, but for a far larger plant itself?
So you mentioned the digital twin. If I'm right, that one is on your, let's call it first generation technology. And you're about to deploy second generation technology there as well.
Yes, and I have to be very careful not to use digital twin too often. Our engineers and the people inside didn't really like me calling it that necessarily because it's a set of models which we've set up. So at the site, we were able to run the DLE system in a certain configuration. We had the blessing as well of being able to take the technologies really up and actually beyond their limits of normal operation to stress test them. And we broke quite a few things as well. We tested as well different membrane technologies to see how they would perform with a live brine. But most importantly, we gathered 78 million data points with which we can then validate our models and see, okay, what does this mean in this kind of a configuration? What does this mean if we're using this technology? And we're able to test a couple of those technologies and certainly stress test the theories which we have also for future generations of DLE processes.
So what struck me on that specific site visit is that you act a bit more than just as technology supplier. You seem to be co-developing the project with Northern Lithium. So is that your approach to all projects, or is it, that one is in your backyard, so you have to serve the customer above and beyond?
I think it's project specific and it's customer specific. And in this particular case, as I said, Northern Lithium extremely entrepreneurial and decided, well, you know what? Rather than building up all of this technical expertise internally, we'll just rely on a partner that we think can get the job done. And that gives them a lot of advantages in terms of speed and moving quickly. The disadvantage, of course, is that it is a lot more risky. But I think if one of the messages that comes out of the podcast today is these are people who are willing to take a certain risk because there are advantages in doing so, not least shorter project times. And actually, economically, as long as the risk comes off, it turns out to be, a pretty good deal.
So what does that mean in concrete terms? Does that mean that they are still buying from you and you're a supplier, or does that mean you're also co-developing and you have some success shares in their project? As
I mentioned the economics before, we've shared a fair amount of the risk as well on this particular project. And it being our first on-site big-scale deployment, there is risk involved with that. But we were quite happy to share that risk and help not only the client, in this case, do the DLE section. And for us, DLE, by the way, starts with a raw brine, with no pre-treatment, with nothing, as it comes out of the well, and goes right through to a lithium chloride or a lithium sulfate product. We don't include the conversion step into lithium carbonate or lithium hydroxide. We have many partners that can do that, but we do really look at it more or less from an end-to-end perspective. Even the conversion part, we have a good understanding of, and we match up our processes to what's coming next. So that's an important qualification. And I think, there was a lot of reliance on our expertise, experience, some of the insights we've gained also from processing a lot of brines at our own facilities at the DLE test center, which we have close to Manchester in the UK. So relying on that and then executing on it has been, I think, a big part of what we do. And then in terms of sort of partnering on a project like this, I mean, the industry itself, as you know, is a nascent industry. It's all pretty immature, and you just have to get more involved than you might do in other sectors, or even more involved than potentially you want to do long term.
You said something super interesting here, which is your DLE scope. Because I had that conversation with several people who told me like, you know what, everybody's like saying DLE is complex, but DLE is not complex. DLE is just extracting some lithium. What's complex is a pretreatment. And I think what's important here is to have a right set of definitions. When you say DLE, it includes the pretreatment. So what you're saying is that you're taking everything from raw to sulfate and chloride. And I know that that's a perk of Evolve that basically with a switch, you can go from one to the other pretty fast. But does it need to be defined more accurately so that everybody speaks the same when we hear the three magical letter DLE?
Well, I think there's been a realization that some of the claims that have been made in the open marketplace and at conferences and maybe even on podcasts have been without the kind of qualification of what that claim is supported by. And so you get some clients that we're in contact with saying, oh yeah, we've come across this DLE in the past and this does this and this, but we have to provide the brine in this certain state. So there is a lot of pre-treatment that goes on. Now, managing a well in itself, production well, and then a reinjection well is an art for itself. That's a science on its own. And we don't profess to have any expertise in that particular area. That's something which we also expect a customer to do. Once the brine is flowing in a stable state from the well, we do take it from the raw brine right through to, as you said, chloride or sulfate. And that can include really interesting contaminants, hydrocarbons, arsenic, and other toxic substances. Of course, a lot of suspended solids, and the all-important for the DLE process, divalent ions, the calcium, the magnesium, strontium, and other multivalent ions, which are the most corruptive part, if you like, of DLEs and where DLEs either fail or succeed.
I wanted to go that later in the conversation, but I'll take it here. If your strength is so strongly in the elements that your pre-treatment or your absence of needing a pre-treatment, depending how we want to define that, is an absolute perk of your system, would that mean that you might be the perfect universal first step to a lot of other DLE brands?
We certainly see our sweet spot in that, if you want to call it pre-treatment step. So from the raw brine through to a pretty pure monovalent stream of lithium and sodium, potassium, or if there are divalents in there, even the step before that, removing suspended solids and hydrocarbons, dealing sometimes with high temperatures, strange pH levels. That really is our sweet spot, definitely. And we do collaborate with all kinds of people on their flow sheets as well, and made a public declaration together with what some people might consider competitors in the DLE landscape, that we're all going to work together and unbox the black box and have transparency in where each people's sweet spot is and how everyone can contribute to bringing lithium supplies into the marketplace outside of China and using DLE technologies that also rely less on global supply chains.
We mentioned the acronym DLE. I think when Chris was on that microphone, Chris Wires, he was mentioning the acronym ICP for Isolate, Concentrate, Purify. You made clear that Purify is something that you can do at lab pilot scale, but that's not what you want to do long term because lots of people on the market can do that. And then there's Isolate and Concentrate. And what we're discussing here is that your approach to removing all the divalents would be isolate, then concentrate would be like just putting all those lithium elements closer together with less water around. And the absolute perk with your technology is in the I, even though you can do the I and the C.
Perks really follow the flow sheet right through to the very final battery grade product by removing the divalent ions at the start, and we get in our lithium chloride and lithium sulfate undetectable traces of divalent ions, as close to zero as you can actually get in terms of measurement terms. And we don't know of any other DLEs that take it to that level. So we don't need any further polishing. That's directly off the back of, we use typically an ion exchange as the last part of our process. So that's directly off the ion exchange without any further concentration or polishing or anything like that. And the reason is that we're doing all this highly selective separation of the divalent ions right up front with our advanced nanofiltration membranes. But that has perks for the overall process flow and the amount of systems and CAPEX and OPEX associated with the overall process end to end. But it also reduces, if you like, the effort on the back end for converting the lithium chloride and lithium sulfate into a battery-grade product. So typically the purity of the back end of our system in a lithium chloride and lithium sulfate form is 95%. Northern Lithium, we got up to 96.2% purity. And anything in the 90s is, I think, quite outstanding. I certainly know publications from other DLE companies that talk about 82% purity. And this is not to be confused with battery-grade lithium carbonate and battery-grade lithium hydroxide, which has to be 99.5 and above. But what it means is you're starting in that conversion stage already with a higher purity product, and the effort to get to 99.5% battery-grade products is much reduced. In fact, one of our partners says, okay, you're going to need 25% less CAPEX, 22% less OPEX for that conversion stage. We don't need to do any polishing. The concentration of our eluate as well is 5,000 ppm of lithium metal. So, between 30 and 60,000 ppm of lithium chloride. So the concentration is already quite high. And in some conversion technologies, that's already suitable. The perks go further though, because if you've got rid of the divalent ions, the waste streams coming off the DLE systems at different places are more easy to recycle. This is why we can take the water stream, which is only really sodium and water and potassium, monovalent stream, but no divalent, and use a very small RO system to recirculate enough water for the DLE. So we have a zero water footprint for the direct lithium extraction plant. Similarly, for any chemicals, so we use an ion exchange process. It uses hydrochloric or sulfuric acid. We also need bases to be able to CIP, clean the systems. But guess what? One of the waste streams of the ion exchange is a highly pure sodium chloride, no divalent ions. If you put that through a bipolar electrodialysis system, we've not got any scalants, so the BPED works quite efficiently, and you can split it into your sodium hydroxide for CIP and your hydrochloric acid, for example, for the ion exchange process. So we also offer, in most cases, a zero chemical footprint DLE system. And that's all related to the perks of removing the divalent ions right up.
Sorry to interrupt, but I wanted to quickly thank my sponsor, Simple Lab. If you're in the water industry, Simple Lab has you covered. Simple Lab is your one-stop shop for certified laboratory testing kits, from routine lead sampling to walk-ins and specialized analyses like microplastics, PFAS, and RADs. Order the testing you want online, choose from hundreds of accredited commercial labs, get free round-trip shipping both ways, and by the way, if you have your own lab and just want help with kitting and logistics, Simple Lab can do that for you too. No more coordinating labs, chasing shipments, or wrangling EDDs, just streamlines ordering, clear results, and real support when you need it. It's lab testing simplified. Head to gosimplelab.com. It's the first link in the description. Choose your test and they'll take care of the rest. Thanks again, Simple Lab, and back to me. I know that you're a well-behaved British and I'm a crazy French guy, so I'm gonna give names, but you don't have to nod or to go along with it. I was at a DLE full scale, and not so many full scales, last year in Argentina. Just to give a comparison point to what we're discussing here, and the way they do that pre-treatment is nanofiltration reverse osmosis, which absolutely concentrates the lithium, but also absolutely concentrates everything else. And so that means they have down the flow sheet to deal with the divalence when your approach is less standard. Of course, it's not like you can go off the shelf to any distributor and buy your nanofiltration membrane and reverse osmosis membrane, which are pretty standard in the desalination world. So there probably is a cost element to it, and there probably is an element of novelty and risk readiness to it, but it comes with the perk that you don't just have everything in a concentrated mixture, you have things a bit more separated, if not fully separated. So that is my 2 cents translation of what you said. Before we go into the depth of it, I have a last stop, which is I discussed with Chris, as I mentioned 2 years ago, almost day for day, what is the big difference in Evolve 2025 compared with Evolve 2023?
The more you learn, the less you understand. Someone sung, I think we now know all the things that we thought we knew, but probably didn't know back in 2023. We understand how much we don't know. That's probably the absolute statement there. But we've taken what was essentially theoretical knowledge, some lab-based knowledge, a little bit of pretty good and interesting technologies, now not only to commercial scale, but large-scale industrial scale. And we've done it in partnership with others. So you mentioned before, perhaps the technology is not commercially available off the shelf. To some extent it is. The major advantage really, and part of our philosophy, is that we do not really disrupt existing systems. We try to make things as easily adoptable and scalable as possible. This is a basic Evolve philosophy. And so being able to use our technologies is not necessarily something we want to make an exclusive right and only for a few selected VIPs that can get hold of it. We want to make it widely available at scale through partnership. And that's also something which we've proven out pretty successfully now in terms of the base technologies, but also in terms of the engineering around the DLE. And one key difference in our mind in the way that we approach things and others in the lithium space are approaching things is we go about it from a water treatment mindset, not from a mining mindset. So to contrast the two, mining, you may see very large plants, usually quite bespoke and customized to a single situation. Water treatment, you tend to see decentralized, smaller, modular, but also scalable systems. And very importantly, they are systems that really very, very many people on the planet can understand and engineer a solution around those systems. It's not rocket science. It's familiar water treatment technologies with the added, perk, if you like, of this, the way we apply it and the base extra boosting technologies which we add to it. But even adding those enhancements is something which we license out to other partners. And we have examples around the world where people apply their own coatings, their own 3D printed elements to base membranes and make them better.
What you just said sounds to me like something which needs to be repeated and repeated and repeated, because it reminds me of something I discussed with the CEO of Vulcan. I was telling him, what you do is a complex project. He was saying what you see as a complex mining project is a simple oil and gas project. And to which extent he might be right, he might be wrong. I don't know. I'm a water guy. But as a water guy, when I'm listening to all the people explaining to us that, DLE is complex, it's difficult. Yeah, for a mining company, it might be. But from a water perspective, it's daily bread. It's another decentralized system, maybe a bit more specialized, maybe a bit more specific in the technology it uses, but in the approach, it's a water topic and it's not that complex. I know far less in lithium than what Joe Lowry will forget every single hour of his life, but still every single time I hear Joe discussing on his podcast around the topic of DLE, I'm like, but it's a water topic. And as a water topic, if you give it to water people, it's not that outlandish. And I believe we can manage. But I think that's an education topic to bring to the mining sector to tell them, it's not that risky when millions of people are using very similar technology in the world, and you're going to find people who can help out with that. And I think to that extent, what you're doing with opening the black box helps with that, because all of a sudden it's no longer black magic, it's steps which can be explained. So let's maybe take it from there. Opening the black box is something you shared last year. And what's the background to that? What took you to that realization that that was the next step to be done?
Well, I think for each individual project, each individual client, there is no silver bullet. And so being able to really have almost like a set of Lego blocks which you could put together in a certain way for an optimal project as a wise approach moving forward. Of course, we would say that because one particular Lego block, as we've said already, kind of the pre-treatment Lego block, if you want to call it that, is something we're particularly good at and don't have, to be honest, a tremendous amount of competition in there. Also because we've protected it patent-wise. So we're quite confident in our IP position to be able to say, whatever flow sheet it is, we can bring this in and this is our value add. So that's a nice position to be in, I guess. There is a lot of concern, however, of course, about IP leakage. And I fully understand the hesitancy also from our side to be super open with every single potential partner you could meet on this whole planet, shall we say. And so when you're at a conference and everybody's listening in, of course, you're going to be careful. But at the end of the day, we've got together also after this announcement with all the partners we made the announcement with, and we've actually matched up our flow sheets and we've said, okay, where are the relative weaknesses and strengths? And it's been good. And none of us, you'll have noticed, will have spoken publicly about the other's weaknesses. Quite the opposite. It's about how can 1 + 1 be more than 2? I think that's a real positive development. If I can touch quickly on water processing and oil and gas, there's no coincidence it's the new energy divisions of oil and gas companies and their supply chain that have really shifted their attention towards lithium. And it is quite a natural fit, I think. But I'd also say that Joe Lowry has also changed his opinion over the past few years, let's say even couple of years, quite significantly when it comes to DLE, in my opinion, at least, my own personal opinion. And I think he's also embraced the likes of, there was a recent post from him about Equinor and ExxonMobil and the work they're doing in the Smackover. And he's embraced that and sort of said, well, yeah, these guys really get it. They've got the resources. They've got the technical know-how. You know, even in these challenging times, I think you describe it as a lithium winter, these guys are going to make it. And what are they? Essentially, they're water processing companies with a little bit of fossil fuels if they have to. But it's about liquids. It's about scalable, modular, standardized systems which you apply to treating liquids.
That was no beef to Joe. I'm learning every time he publishes a new episode, so I'm super thankful for him being in the space. But to me, it's just symptomatic of whenever you come with anything linked to spodumene or evaporation ponds, he knows that ins and out because he's done it. Whereas DLE being a bit more recent, even though you can argue it's in the field for 20 years, it is still a field which is scientifically and technically interesting, but not practiced every day by operators. And you're right to say that there's a change between if you listen to Joe 5 years ago and if you listen to Joe now. But again, not meant at opening any beef. That's not my aim. You said something around the different partnerships. Let's be a bit more specific. You've made a partnership with Zelendes, which surprised me, to be honest. And then also partnerships which are a bit more logical to me, for instance, with Altilian. What takes you to work with Zelendes, which, yeah, I would deem to be your competition?
I mean, firstly, it's not an exclusive partnership. And secondly, we have ongoing partnerships with direct competitors, DLE providers in a very healthy manner. But in terms of Zelendes are really strong in terms of being able to advise our clients in general on their brine situation and how to get things rolling, and also help them prepare for permitting applications, financing applications, etc. But Zelendes, when we first got to know them, had just kind of launched their decentralized conversion technology approach, designed especially around the needs of Latin America. And so their typical module size, I think, is about 2,500 tons per year of LCE as a capacity. And that, of course, is down at this conversion stage we've been talking about. So we were really keen on trying to deploy decentralized DLE directly at the wellhead of small geothermal wells and produced water from oil and gas operations. Those wells are typically not massive amounts of water coming out of them. And then being able to have a decentralized conversion technology. So that was really, in our mind at least, a main ambition of partnering with Zelendes. And as I said, we've matched the back end of our system to the front end of their system to see where's the optimum. And that's not about creating any form of competitive advantage, because we're not exclusive in any way with each other, but understanding what it takes and helping the customer get a better solution. The other part about Zelendes, of course, which is not exclusive to us partnering with them, is that if we give them as much knowledge and insight on our DLE, they have a DLE advisory service for lithium producers. And then they understand, okay, where can the Evolve technology or the Evolve flow sheet come in best? How does it stand up versus other competitors? And they're in a better position to then just advise lithium producers, hey, you probably need to speak to these guys or these guys. And that's just a general thing that we try to do, and something I appreciate as well with you today, to be able to just give some insights as to where we're at, what we do, what our strengths and weaknesses are.
Have you ever heard of a membrane that refuses to break? It sounds uncommon, but it's true. Meet Bluefoot Membranes, a Belgian company that has developed the first and only unbreakable membrane specifically designed for MBR. If you're new here, membrane bioreactor applications. This technology is setting a new standard in wastewater treatment. Water engineers and industry experts have tested this membrane, and no matter how much they pull and twist, the membrane holds strong. Now, it's not just about membranes, it's also about an award-winning and passionate team that doesn't take impossible as an answer. The people at Bluefoot Membranes are driven by a mission to make wastewater reuse the new standard, united by a shared purpose to leave a blue footprint on the world. So yes, they manufacture cool membranes, but they also push the boundaries of what's possible in MBR technology. To learn more about them, check the link to their website in the description. A big thanks to Bluefoot Membranes for sponsoring this episode, and back to me. Let's discuss your technology, because we are talking 1 week before the Global Water Summit, at which I heard you might be doing a soft launch of Separonics. So where are you at in terms of technology, and what is Separonics today, and what do you want to achieve with that soft launch and beyond?
So we talked about the positive attributes of water treatment technologies, and when it comes to membranes, you're able to do water treatment of some form or another at a very large scale, modular, very efficient. And, we have millions of membranes working in the world on all kinds of different water treatment challenges. The technical challenge with a membrane is if you, in your plant, look at how the same membrane from the same manufacturer are performing, you may see quite large discrepancies. And if you've got 6 different membranes, you're going to see a big range of flux rates, rejection rates, etc., energy consumption, pressure drop. That is because of the way that membranes are manufactured. Essentially, you are using conventional 1950s and 1960s techniques to etch in porosity to plastic sheets. Now, 3D printing has not been applied in that way to the manufacture of membranes. And so we tried on the one side with coatings and other enhancements to kind of overcome the variability you have in membranes and make them perform more consistently at a higher level in terms of selectivity and flux rates and anti-fouling. Great. But the base membrane still has its imprecisions, shall we say. So we just said, okay, how can we get over that with modern additive manufacturing with 3D printing? And the journey has been quite a long one to get to Separonics where we are today. And we are in the stage now where we can speak with quite a lot of validated data around the performance of Separonics for some very specific applications. So the journey in Separonics has been, how can we take what we know about printing things with additive manufacture and apply it to structures which look like membranes and perform like membranes? The answer is ceramic materials are very well understood, and ceramic membranes offer certain advantages for certain applications. How can we combine, if you like, the advantages of a polymer membrane in terms of cost and economics and volumes they can produce, and also reliability, with the advantage of ceramics in terms of robustness, being able to deal with very harsh fields? And the answer is Separonics, essentially. So we had to take the whole world of ceramic 3D printing almost back in time, because over the last 10 years, ceramic additive manufacturing has gone towards density and large parts. We want porosity, and we want microstructures, very small flow channels within filtration technology. So we had to go back really almost 10 years and look at the state of the art back then. And we built from that. Fortunately, that area was not well patented, so we're also able to secure our IP in that space. But then how do you print so that you're not having the same challenges that conventional ceramics face in terms of the shrinkages, fissures, fractures, and breakages, which you get predominantly from the sintering process? So we had to come up with a process which is more benign in terms of shrinkage and wastage, essentially, in the manufacturing process. And you've spoken to many users of ceramic membranes, sometimes even when they receive a new box of freshly quality assured ceramic membranes, they've broken in the post. And this is how difficult they can be to deploy. We wanted to get past that, and we think we've been successful at doing that, at least at our scale. The next part of Separonics is then taking it right through to mass manufacture at industrial scale, where where we're talking about thousands and thousands of membranes and not just a handful or a few dozen over a certain amount of time. And that's the challenge which we're currently going through with a variety of interesting partners.
There's a lot to deconstruct in what you said. I have 5 points. Well, let's start with the first. You said very specific applications, to which I hear not just lithium. So what are the other applications in which you intend to roll out Separonics?
The good thing about the pre-treatment, if you want to call it like that, of the DLE process is that you've got to deal with suspended solids, hydrocarbons, high temperatures, etc. And these are things which are prevalent in terms of how they affect membranes in many other sectors. So we really cut our teeth and have widespread deployment of our technologies in the produced water scene. So waters which are being produced during oil and gas production. Guess what? They also contain lithium quite often. Not always a lot, but enough. But if you can deal with Separonics, with produced water, you can almost deal with anything. And so a large amount of our testing on Separonics with external partners as well. We've done it in our own facilities because we like to keep control at the stage of that development of Separonics, but with a lot of consultation with external partners in the oil and gas sector has been around oil and gas related produced water challenges. So dealing with particular suspended solids, dealing with hydrocarbons. So we've done testing on hexadecene, D80 rejection, all kinds of crude oils, all kinds of stuff, and just thrown it at the membrane and see how it performs. So produced water is definitely an area of great interest. I think commercially produced water provides tremendous opportunities also for lithium, but also for unconventional water sources. So if we look at the Permian Basin of West Texas, just to go into one area that we've looked at quite intensely, the Permian Basin is scheduled to produce something like 25 million barrels of produced water every day, which is about 5 million cubic meters a day. That's a lot of water. That water today is a cost factor for the oil and gas producing companies. They typically contract dealing with that water to midstream water treatment companies, essentially. But what if we can not only harness some of the minerals in that water, but also take it to a purity level that it's then interesting for things like data centers, semiconductor manufacturing. And guess what? West Texas has a whole load of solar power. It has a lot of skilled workers. It wants to attract high-tech industries. What's the limiting factor to do so? Water. So if we're able to tap into unconventional sources like that, essentially in a more circular approach than today, harvesting what we have, we don't have to tap into very scarce, often natural water reserves, and we can harness the opportunities which we have there. But guess what? It takes really good filtration technologies. So those are the things which we're thinking about in a produced water field, lithium extraction through to desalination, even ultra pure water generation. It's an incredible amount of water which you need in our modern new information age. And water is going to be a real limiting factor to moving to the new energy economy.
It's a topic we discussed on that microphone with Will Hughes from Amazon Web Services. And I heard we'll continue somewhat that conversation on Tom Ferguson's podcast. So I recommend that one as well. Very good discussion, better than mine, because my discussion with Will Hughes was when I was suffering the flu, so I wasn't in my best shape. But
you got the ball rolling though, Antoine.
Now, if I'm right, you're not talking out of thin air here. You had a project in the Permian Basin with water. So tell us about that one.
So the Permian Basin has lithium concentrations of between 20 and 40 ppm from West Texas into New Mexico, if you like. And so most people say, oh, you know what, there's never going to be enough lithium in there to make it worthwhile. However, at the same time, beneficial reuse, as the term goes in the produced water scene. So taking that water and not only re-injecting it, using it for something else, that is starting to really emerge as an interesting topic. Part of that is driven by regulation because of the high re-injection volumes per day, at a certain time that have been put back into the ground. There's been concerns about seismic activities as well. And so regulation has started to actually restrict the amount of water that can be re-injected at certain sites in the Permian Basin. So we have to now do something with the water one way or the other, whether we want to or not. The worst case scenario would be you just waste it. Don't waste water. I think there's a good podcast show based around that whole principle, right? So we took a good look at some of the brines with a very willing customer, with another partner, which is very good in a desalination process, which is prevalently used in oil and gas. And we looked at pre-desalination lithium extraction and post-desalination lithium extraction, because in their process, you get not only a purified water stream, but you get a highly concentrated stream with all kinds of minerals in it. We were able to establish that we can get the total cost of production of lithium, again, from raw, produced water, no pre-treatment, nothing special. Okay, it's degasification has happened. Some of the basic things that happen at the wellhead have gone on. So it has been pre-treated to a certain extent, but it's still got hydrocarbons in it. It's still got all kinds of suspended solids. It's got all the divalent ions right through to a lithium carbonate product. And that's possible at under $10,000 for a ton. Part of the reason is that the brine is already being produced. And so if you look at the Boston Consulting Group's very good report about DLE, they'll say that the DLE typically captures something like 35% of the project cost if you have to start drilling holes. But if the brine is already flowing, the DLE cost is something like 50%. So it's already a big change. And Mark Machado at Fast Markets in Las Vegas gave a presentation on exactly this issue last year from Hatch and talked about DLE. That's only actually a fraction of your project cost. You got to look at everything. So produced water already has all this tremendous volume of water coming out the ground. They've got to do something with it. Why not take it through a series of harvesting processes and use it beneficially?
You made me read that report, and I have to say it was an awesome recommendation. So I'll put in the show notes if more people want to read that BCG report. Really interesting read, and also good to see somewhat people not from the trenches coming with same conclusions than what we might be rambling about. So really good read. Thanks for the recommendation, by the way.
Allow me, if I may, to be a myth buster in terms of one recommendation from the report, if I may. And we had a client that was really keen on a decentralized production, like we've been talking about, water treatment technologies, smaller scale, decentralized, scalable. And the Boston Consulting Group essentially recommend that A, you need to have 250 ppm of lithium in your brine to make the economics work. And B, you should really be thinking about 10,000 tons a year of production capacity of LCE. We have proven, in our mind, together with this customer, for this customer, in a proper study, not just superficially a bit of desktop exercise, but a proper study, that we can stay well under the economically viable curves that BCG suggest, even though we're looking at a plant of 500 tons, for example, and way less lithium than 250 ppm. So I'd like to bust that myth slightly. And the reason is we're going at it not from a mining mentality, but from a water treatment process mindset, which is what we've been talking about.
Fair add-on, very fair. Coming back to your Separonics point, I mentioned 5. We covered 1. Let me go to the next one. You have a very bold claim when you say that you want to marry the usual perks of ceramics with the costs and robustness of polymerics. The saying in ceramics for decades is, it's better in everything but costs. If you bring costs down, and it's going to be coming down, I think we discussed that like 5 years ago on that microphone with Graham Pierce, volume brings costs down, so ceramics are going to take the market. Still, ceramics today is 7% of the market, polymerics is 93%. So it's a bold claim to say that you can be going in the cost waters of polymerics. What makes you confident that you have a path to glory?
Well, I think even ceramics have come down tremendously in terms of the tag price, the ticket price, and in many areas are very competitive compared to some polymer solutions. But again, it's about horses for courses, as we say in English as a phrase. What application really requires a ceramic solution? But we are seeing widespread use of ceramics, even in a drinking water, surface water treatment. If you look towards, actually the UK has the world's largest ceramic membrane-based surface water treatment plant in the world. It will soon be Singapore, but that's not yet fully operational, whereas the one in the UK is. And those are made with ceramic membranes that are very, very cost competitive. The question is, A, what application are you going after? And polymers will continue to trump ceramics in many, certainly where it's more of a commodity, if you like. But B, you have to try and compare apples for apples. And one of the unfortunate things about ceramic membranes, because of the way they are manufactured, is they have a relatively small amount of active surface area compared to a spiral wound polymer membrane. So Separonics addresses this already, because we don't only use the shell of a tube as a membrane filtration wall. We're using all of the intricate flow channels which are printed into the modules as a filtration. It has porosity in it as a filtration wall. And so you're already multiplying the active surface area by a lot. And to tell you the truth, it's extremely difficult for us to measure that. And so we don't tend to talk about active surface area in terms of comparisons. We talk about a specific feed and the capacity of a filtration technology to process that feed in terms of speed, flux rates, and also in terms of rejection rates. And so on the hexadecene test, which we've done, for example, we're rejecting 99.1% of the hexadecene. You probably will struggle to find any other polymer or ceramic membrane that gets to that level of selectivity. Question is, are you sacrificing flux? And the answer, at least with Separonics, is definitely not. In fact, because of the flow channels, because of the superior precision we can get in the actual productivity of that module, the flux is extremely interesting. So if we're comparing, shall we say, cubic meters of a specific brine processed and the outcomes in terms of the permeate and the retentate, then that is the measure, if you like, of what we're doing. In many hydrocarbon removal processes using membranes, you need multiple banks of membranes. We can do it with less banks of membranes, less passes. And in fact, we can also alter the filtration profile across the module. So we can start more porous with larger porosity, larger holes, and we can go through to finer and finer and finer rejection porosities through the actual module itself. This is all the kind of thing you can only do with 3D printing. To be realistic, we have work to do in terms of the manufacturing of massive amounts, and we fortunately have numerous very interesting partners, some household names, which are keen at looking at this, not only from a 3D printing perspective, but in terms of the entire value chain of manufacture. These partners, to be honest, have looked for applications where they can work with a volume piece at large volume, because a lot of ceramic additive manufacturing is focused on dental implants, hip replacements, these kind of things. And there's not a lot of business to be had there. And the actual volumes are relatively small. The applications are relatively simple. And so at one major additive manufacturing show we went to in Germany, we were put on the booth by one of the partners I mentioned before as a really interesting case study for taking additive manufacturing to a very large industrial scale and a very interesting application. And we were overrun by people on that show. And they're all additive manufacturing people. They're looking for great opportunities. And the industry is not in great shape, to be honest. So it's natural. But we really believe that additive manufacturing can help crack some of the limitations of ceramic membranes and still replace some of the polymer membranes in specific applications that they struggle with.
Which is the perfect segue to another point I wanted to discuss after your Separonics introduction, which is the manufacturing itself, in the sense that when I spoke with Chris 2 years ago, all options were on the table still, that you might be an IP company developing stuff and then somebody else is going out and building. You might be a 3D printer company, which is then selling those 3D printers to others so that they print it. You might be a membrane company. You might be a membrane module company. You might be an end-to-end solution and a service company. If I hear you now in between the lines, let's say, what you're doing here is becoming that IP company developing cool stuff, which then gets mass manufactured by partners.
That's a perfect observation. And I think it would be wrong of Evolve to sort of claim, yeah, we're going to be, a mass manufacturer and have 500 manufacturing sites locally all around the world and be this massive company. That would take us a long time to establish. That's the one point. Related to that is the fact that, to be frank, the capital investment markets struggle to support such very large investments in capital-heavy industries right now. But more importantly, what we've discovered is from having to develop a lot of stuff in-house, also to understand how it works, does it work, and having also the personnel on board to be able to manage that process, not to be surprised, as by the way, other water treatment technology companies that have tried additive manufacturing out and struggled in certain areas, not to be surprised because the 3D printing process doesn't work as they had anticipated. So we've got past that, we've got the maturity in the product, and we've built our own printers, our own sintering processes. We understand that. We have material scientists on board. And now we're able to speak to a very large partner that understands that very, very well with a certain level of expertise ourselves, and to say, okay, We understand that. Also to challenge them and say, okay, have you thought about this, because this is what we're facing here. So all this is new. And I think one of my favorite phrases, which I know is attributed to Steve Jobs. I don't think it came from him, and I forget who it came from originally. You probably help me in a moment. But he says, if you want to go fast, go alone. If you want to go further, go together. And that's exactly the philosophy which we've embraced. And so we've been able, very fortunately, with all of our technologies, to find both, shall we say, manufacturing partners, as well as distribution and commercial application partners, be that other membrane companies, be that system integrators and EPCs, who are helping take those technologies to the marketplace.
How much of that is willful strategy and how much of that is realistic and a logical take at the state of the market today? Because let's take just another one in your lane, which is Lilac. Lilac has raised 300 million over the past 3 years and is about to close another big raise to cover their demonstrator in Salt Lake City. You, in the meantime, have raised a sizable 16 million in that sector. That's absolutely not nothing. But if you have to fight with equal arms against a Lilac, you mechanically have 20 times less cash. So is it by design that you don't want to be like playing the arms race game? Or is it a realistic adaptation where you say, yeah, there's a clever way to deal with that?
I think it's dealing with adversity more than a sort of an active choice almost, if you like. So we're based in the UK. I actually spoke more recently at a government-related event about adaptation of innovation, and everyone was celebrating, how great the UK is at coming up with novel ideas. To be frank, you find some fantastic inventions, whether it be in pharmaceutical business or even heavy industry, great things here. What the UK is not great at is providing the right environment to take that from a small industrial scale to major big marketplaces. And it's not because we can't engage with the marketplace, it's because the capital is more readily available elsewhere. And so what you often see, and we were faced, and are faced, I suppose, with the same conundrum, is that if you want to really get big capital involved, you have to consider, as a Western company at least, going to North America, especially the US, where there's a lot of inventive power as well. Just look at all the things we've got in here, invented with great American taxpayers' money to a large extent. The CIA invented a lot of stuff in our iPhone today. Taking it to the next scale is something that America is really, really, really good at. So that's a general comment. Also, the capital investment markets are cruel at the moment for a technology company. It's not easy. And we address really 3 different marketplaces. We address lithium. So lithium is in its winter, as you describe it. Really tricky to get investment into that sector at the moment. Secondly, additive manufacturing. I think you can say that additive manufacturing had a massive hype growth period, loads of acquisitions, consolidations, massive investments, but it's rebound from that in, well, a pretty sorry state in some cases. I mean, great potential. Has it fulfilled all the hype and the potential? Certainly not. So it's difficult to get investment into additive manufacturing, which leaves us with water. And you've covered the whole investment scenario into water technologies in particular very gracefully over recent podcasts and have highlighted some of the opportunities, but also the great challenges in there. So as Evolve, to be frank, it's been quite a challenge raising capital because of those factors and then not being based in the US. The other thing in a DLE context is you'll see that just about every DLE company except for Evolve has purchased an asset, a lithium production site of some kind. And Lilac is the same at their site in Utah. And, EnergyX have done the same. You could say Geolith have formed a partnership with KBR and are doing similar things. Essentially, we don't have that luxury. And therefore, being able to partner with a client like we've done at Northern Lithium, and we have other similar partnerships, which are starting to mature in Europe and the UK, is absolutely essential for us to not go with a finished solution onto a site like you saw at the end of March, but to actually be able to experiment, try things out, push the technology to a limit and do that in a controlled environment where everybody's safe, but also without the expectation that the commercial viability is going to be proven overnight. It's not a plug and play system. The DLE is still a complex thing, even though the concept is not necessarily as complex as it was, as we've discussed. Getting it up and running, optimizing it for a particular project getting it tuned into production mode, into a steady state, reaching equilibrium on the membranes, it's still quite a complex operation, a project like that. And so being able to do that on your own turf, in your own back garden, with an asset that you own, gives you lots of opportunities to try things out. It also makes you a lithium producer. And if you can secure, the rights to that lithium, which is not easy, and if you can then get offtake agreements, it's an attractive business to be in medium and long term, even if the spot price at the moment on the Chinese market is not great.
What you're saying here makes an interesting parallel to a conversation I had with John Webley from Trevi Systems, because 10 years ago, there were several forward osmosis companies and probably some which raised more money than Trevi and went more aggressive and went bust as well because the market didn't move as fast as they needed in order to recoup their cash, whereas Trevi is still here and building strongly around that. So playing the turtle in the turtle versus the hare race can be a good strategy. So just that being said, you mentioned partnerships in the making in Europe. Question coming out from Canada here. I heard you're working with MVP in Canada. Do you have more projects like that coming in North America?
So you mentioned a partnership agreement with Altilian, which is a very interesting technology company, sits slightly downstream of our flow sheet, can replace parts of our flow sheet. They're based in Houston. And part of our non-exclusive MOU was, let's work together on some of these projects. Let's have your technology over in the UK. We'll put our technology over in the US, etc. And that is a very interesting way of capitalizing on some of the projects which exist in North America. Another interesting way is to set up full operations to be able to profit from that. But as you probably are well aware, at least in the US, I think independent to the Trump administration, and in some case, the legacy of the Inflation Reduction Act not being physically based in the US is quite a barrier to engaging in those projects. Even if you've signed a trade deal between the US and the UK and got over some of the current tariff discussions, shall we say. So not having a base in the US has definitely slowed us down in terms of being able to execute on some of those promising projects. We are engaged with them. We have several projects from the Salton Sea right through Texas into Arkansas, into some parts of the West and even the Northeast of the US, and then have been engaged in projects to a certain extent in Canada as well. And MVP is an early stage project which holds a lot of promise and where we've had a good exchange on, what could be a good potential approach. It's not, again, any kind of exclusive relationship, and we generally shy away from those kind of arrangements, partly as well because they may decide that only one part of the Lego collection is suitable for their project. And if it can be an orange piece of Lego, we'd be really happy if it's just one piece of Lego, not the entire process. But there are some very specific challenges in North America. If you look at Canada, the relative amount of lithium compared to the amount of calcium, for example, in the feeds is generally tricky, more challenging than in other areas. If you look at some of the areas in the US, you also have high levels of TDS. But if we go to the Salton Sea, those brines come out the ground at 600 degrees Fahrenheit, in some cases 280 degrees C. They're full of silica. They're full of transition metals. The instant they are exposed to atmospheric conditions, things crash out, and that's pretty tricky to deal with. It'd be great if Separonics would work in that kind of a scenario, wouldn't it?
That's a great teaser. I take it. Do you have actual early proof of that? Like you have seen stuff which you cannot share yet, but which makes you believe that you can make a bang with that?
We've worked on the same kind of suspended solids which you would expect to crash out. And we've worked on them also in solution, not in the field as yet, although we have come across similar things in the field, but we've worked mostly in the lab, also on Separonics, and we have some good successes there. The quantities of stuff in those brines and then the temperatures at which you operate, that is something which we still need to really look at in the field. But we know that Separonics, which our first generation of Separonics are alumina based, they can handle high temperatures. That's not the issue. But how can you plug them into a system where you're keeping the temperature high? You're not necessarily releasing the pressure. You don't have a pressure drop on the brine. You're keeping the pressure at whatever it is. You mentioned, a German DLE project before. they have similar issues when the brine comes out of the ground in terms of pressure, partly temperature, but less so. So can we keep it at high pressure? Can we keep it at high temperature and still run it through a system? For that, you need extremely advanced technologies. I remember one of the producers at the Salton Sea, who you probably know very well, said that every 10 degrees C of temperature reduction of that brine costs them in terms of OPEX about $12 million a year. That's going to affect your lithium balance sheet quite significantly. That's a lot of money for just 10 degrees, and we're at 280 degrees when it's coming out of the ground. So you can imagine the implications of being able to keep it at high temperature, high pressure, and not have all the issues which currently exist.
It's a double-edged sword, honestly, because the Salton Sea is a graveyard of DLE dreams. If you're able to pull something out there, then you're the one, and that speaks wonders. But if you're just another in the graveyard, then maybe it's because the Salton Sea wasn't meant to be a lithium place in the first place.
But I think you are not going to be the one. And there are successful lithium extraction processes that have worked in the Salton Sea. Have they worked economically? Can they be further optimized? Can you bring down the issues associated with what I just talked about? The answer is definitely there has to be room for improvement, because probably those systems have way to go in terms of their economic viability with current lithium prices, shall we put it this way. And so I don't think there's a silver bullet, as we said earlier. I don't think there's really one size fits all. And if you can use selectively certain Lego blocks, including orange ones, in a flow sheet like that, then that's how you're going to optimize things. You're not going to go to one company with one solution and they're not going to solve everything. Even the big guys, even the best in the world, they have to rely on a variety of different technological solutions for such massive challenges.
Talking of optimization, and then at some point I'm going to be cautious every time and stop pushing stuff at you, but that one I really wanted to take it. We didn't discuss South America yet. I have a colleague in Argentina who calls what SQM and Albemarle are doing in Antofagasta as being kind of a survivor of DLE. Like they've taken in 16 or 18 or 20 candidates, and then they eliminate some weeks after weeks after weeks until only one survives, and then that's the one. I do know that you've been involved and with promising results. Where are you in terms of any plans in Chile?
Well, it's in the public domain that we work with SQM, so we can name that. And I think that the breadth of experience on lithium production there is quite second to none. I actually, by coincidence today, had a call with someone who produced lithium carbonate in Chile in 1984.
Wow.
And so we're looking back at 30 years of experience, and not quite sure, I'm not up to speed on China and when they first started on their lithium journey. I suspect it even earlier than that. I know that in Eastern Germany and in the former USSR, the lithium journey's been quite an old one as well. By coincidence, that's a lot of experience. And these companies know what they're doing, what they're talking about, and they also understand water treatment technologies very, very well, especially in the Atacama Desert and in their operations in Chile. Where do they get the water from? It's predominantly from desalination, and they're very conscious about that. So where are we at? It's difficult for me to disclose details. All I can say is that we had some targets to hit in terms of technical performance of our entire DLE flow sheet. And we did a set of offsite piloting in our own facility, which was successful, and we exceeded all of those targets. That's the best thing that I can say at this current stage. I think that getting back to what we just said before, that there's not one size fits all, there's not one silver bullet. Those are philosophies, or that is a philosophy that SQM and Albemarle both pursue, and they will take the creme de la creme of technology, quite rightfully, and apply it themselves as they see best for their particular projects and their particular situation. And that, I think, is a very legitimate way forward.
As I want to be cautious every time, and as I do know that we will need a follow-up somewhere down the line, so I can leave some of the questions for the future, let me just close that deep dive with this one. How does success look like for you and Evolve 3 years or 5 years down the line?
I think it would be nice if we have very widespread implementation of the technologies, not from Evolve growing and being a massive global player, but from partners in the entire breadth of the supply chain and the value chain, embracing the technologies, being able to apply it under their own steam, with their own expertise for their own projects. And of course, if we are moving more and more to additive manufactured filtration technologies, this provides the opportunity for extremely bespoke, mass manufactured solutions. And so the dream would be that actually we have lots of manufacturing centers around the world for filtration technologies, 3D printed, and that partners, customers can almost get their own floppy disk with their own design, made by Evolve, with Evolve inside, if you like, and plug it into their machine and say, okay, I want 10 filtration systems printed, and that those 10, in terms of the unit economics, cost no more than if they were going to print 10,000. And that's a big, big advantage of being able to set up partnerships to do that. So ideally, people almost forget who Evolve is, where things like Separonics came from, and it's just there and everybody uses it and is able to use it.
And if you reverse engineer that, what needs to happen in the next 12 months?
In the next 12 months, in terms of Separonics development, the prototypes, which we've been testing with a lot of anger in our own facilities, need to be taken to a mass manufactured level. That means not that we've made 10,000 of them, but that each unit does not have the characteristics of a prototype, that it could be one of a set of 10,000. And then that needs to be fully tested in the field with partners, with customers, with end users, because that's where the litmus test is. That's where the real stress test is, when things are running well in the field, when operators embrace it, because it's not really disrupting things, where it's fitting in to existing systems, but taking those systems to the next level of performance.
Well, Andrew, thanks a lot for the tour of Evolve as of today and tomorrow. As I said, there's much more to dig into, and I'm pretty sure we will have the opportunity to do that down the line. To round it up for today, let's go to rapid fire.
It's time for the rapid fire questions.
What is the toughest challenge in your opinion for a water tech startup?
I think diversifying away from a single reliance on one certain market, one certain partnership, but actually not having too many eggs in one basket. And everybody from the consultants through to the investment community will recommend that you really choose a beachhead market, focus entirely on that, and only put your energy into that. That carries very significant risks. And I think it's a big reason why many startups fail.
What would be your best single piece of advice for the founders and managers of the about 1,000 early stage water startup?
Don't be shy to engage with the end user in the entire value chain of what it is you have to offer. There may be forces within the supply chain up to that end user which don't necessarily embrace your innovation. But if you just go out there and speak to the end users, they are developing fantastic mechanisms to do that. The accelerator programs that we've been through with some end users, fantastic. You have direct contact and you learn from the horse's mouth exactly what the challenges are and how you can address them.
What's the drop of knowledge you wish more investors knew about the water sector?
Water is benevolent, and the water sector is a caring environment. That has advantages and disadvantages. I think in the bad times, investors tend to flock towards a safe haven, and perhaps water is one of those. And I think we're seeing that currently. In the good times, even if the investors may jump on different bandwagons, which are, shall we say, sexier, doesn't matter. Water's still there for you. It will still be your friend.
What was your most unexpected partnership and what did it bring you?
We've been able to secure a partnership with a Japanese trading house. I can't name who, but this is $100 billion turnover company, which we aspire to be one day, maybe. No, we don't. Absolutely incredible. And they are very interested in particular in lithium and really investing vertically throughout the lithium value chain. And so they help accelerate some of our projects, offer offtake agreements, even help with project finance for our customers. And the second thing is they're also really interested in trading in advanced filtration technologies like Separonics.
Is it the one I met?
It is.
Super short. Profitability or growth?
Profitable growth.
No, that's cheating.
Growth at the stage which we're in. I think that's essential right now.
What's the next profile you'll hire?
I would say a really professional sales and business development manager or director or VP or SVP. so that I don't have to do it as an amateur.
And you're looking for sector experience or startup experience for that role?
Definitely sector experience and getting under the skin of clients, understanding processes, pain points, definitely sector experience. We have enough startup and scale-up experience on board.
Opening new markets or doubling down on the current ones?
Doubling down on current ones and using the opportunities with those current ones to help the transition to the new energy economy, which is essentially opening new markets. But it's doubling down and making sure that we're helping those very fundamental industries in our society, move the needle, because I think that's where the bigger impact is going to come, rather than inventing brand new market segments and coming up with things which have tremendous impact, but at a smaller scale.
What is that tool nobody speaks about, but you could not live without?
I'd say Yorkshire tea. So, us English and our tea, joke by side. I do take tea with me on my travels, actually, and I like that brand. Everybody talks about it probably, but does everyone really admit that WhatsApp has just become a fantastic tool? People, I think, are really well behaved around it. And if you want to just urgently sort something out with someone, or you want to have, a frank conversation by chat or a quick call, WhatsApp has become a really interesting business tool.
What's the single piece of insight your ideal customer profile needs to hear right now?
We don't disrupt. We try and use the existing infrastructures, systems, processes, and take them to a new level of performance, but we do not disrupt.
What are you desperately needing and want to raise an open call for right now?
Investment. So for the first time in our almost 10-year history, we're looking to take on a strategic investor rather than only a capital and clean tech fund investor. So someone, I think, that can help take our company through their network, through their business, to a new level.
So that's what you'll be on the lookout for next week in Paris.
That's part of the mission in Paris for sure. watermeetsmoney.com. If people are not aware, it's going to be a great event. We're looking forward to being there.
What can and should I do for you?
I think if you can continue to remove the mystique and the myths around water and water technologies, that helps everybody. I believe that sometimes we are a little bit closed off, and a lot of the work which you are doing is drawing attention to the tremendous opportunities within water. So you're helping water to come out.
Well, that's good, because that's something I can continue doing without too much effort. So I appreciate that. You're not asking me to do something crazy and weird. Thanks a lot, Andrew. It was a pleasure. Looking forward to see you in person next week. And I really want to continue that conversation down the line to see how everything you teased and predicted today is rolling out in the next years. So thanks a lot for that.
Well, I hope to share a lot more insights, but I really appreciate the opportunity to shine a light on some of the things which have been achieved, and not only the potential of what's to come, but also what's been achieved up to date. So see you next week in Paris, and thank you so much for your time today.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.